Algebra 2, lesson 88, the distance formula, the relationship pressure volume equals moles times rate times temperature. Rate times temperature. Reduction temperature? We'll burn that bridge when we get there. Okay, so let's start with the distance formula. The distance formula is used to find the distance between 2 points. Here we see the points -2, 3, and 4, -4. And the distance formula, where is it on the page? Hold on. Right here. You know, there's actually 4 ways to write the distance formula. And it's just a variation of the Pythagorean theorem, which we use the right triangle to find the distance formula. But you got to memorize at least one of the 4 versions, and they all work on the same system, so they're not too hard to figure out. But the distance formula is this: the square root of x1 minus x2 squared plus y1 minus y2 squared. Or we could do it this way. We can make it be the square root of x2 minus x1 squared plus y2 minus y1 squared. Or, so here you can see the only change in the distance formula here is I moved x2 and x1, which if you remember from our slope formula and stuff like that, as long as we're consistent in our subtraction of our x and y coordinates, it doesn't matter which one's first as long as we're consistent. So in this case, the consistency is 1, 2, 1, 2. In this case, it's 2, 1, 2, 1. So those are 2 different versions of the distance formula. And then you'll notice this middle sign is a plus sign. So does it really matter if I add this number first? No. So that's where our last 2 variations of the distance formula come in. We could put the y's first. I could have y1 minus y2 squared plus x1 minus x2 squared. And then again, I could do the same thing with the y's where I put y2 first. So the last version of the distance formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. But this is the distance formula here. There's the 4 different versions. Memorize whichever one you want. Now let's talk about how to use it. So let's say we're given the following coordinates. I'll make a couple up. Let's go with -4, 2 for our first coordinate, and then our second coordinate will be 3, 6, right? And we want to find the distance between those 2 points on coordinate plane. So I'm just going to assign the values x1, x2, y1, y2. And then I plug those values into any one of these equations. I'll start with this first one since it's the easiest. So the distance is going to be the square root of -4 minus 3 plus 2 minus 6. If I can solve this, I can find the distance between the 2 lines. So -4 minus 3 is -7. -7 plus, let's see here, 2 minus 6 is -4. That gives me -11. Square root of -11 is going to be, what do we have here? No, we'll just leave it. Hold on. I think we can leave our answers in square root form. Oh, I forgot to square them. Hold on. I thought that was weird. I was like, I'm not supposed to have a negative here. I forgot to square them. So squared and squared. So -7 squared, -4 squared, -7 squared is 49. 4 squared is 16. So 49 plus 16 gives me 59, 65. So the answer is square root of 65, but I want to simplify this answer and make sure that I can't factor it. So I'll go ahead and divide it by 5, and that goes in 13 times. So 65, not factorable. So that is my final answer. The distance is the square root of 65. So that's not too difficult. Now let's talk about the relationship of pressure, volume, moles, the constant rate, and the temperature. Let's see here. So this is the book's breakdown of PV and RT. Let's focus in here. P is pressure in atmospheres, V is volume in liters, N is the number of moles in a gas. Moles is a molecular weight You learn about that in chemistry. Rate is a constant rate of change for gases. That's another chemistry rule. And then T is your temperature. And all we're going to use is this equation, PV equals nRT, to solve our equations. So we'll go ahead and put our formula down here. PV equals nRT, and then we'll apply it to a problem. So let's see here, this problem. They tell us use the formula PV equals nRT to find the volume of a 0.832 mole of gas at a pressure of 3 atmospheres and a temperature of 400 Kelvin. And then they tell you that R is equal to 0.0821, and R will always be equal to that value. It's a constant rate. So we'll take these and we'll plug them into our equation. Ooh, crooked again. And what's going on with my Zoom today? All right. So we need to find the volume. So we already know that that's not going to be known, but we do know that the pressure is 3. So I'll substitute 3 for the pressure times V is going to equal number of moles, which is 0.832, and the constant times the constant rate of 0.0821, and times the temperature of 400 Kelvin. Now, we are going to use our calculator to solve this, but before I use my calculator to solve it, I'm going to solve it on paper for my unknown, which is volume. So this one's easy enough. I just divide by 3. So my volume is going to equal 0.832 times 0.0821 times 400 divided by 3. So I go to my calculator. And we'll start typing this in. I should zoom out a little bit. And of course that ruins the focus. Yeah. Okay, so 0.832 times 0.0821 times 400 divided by 3. And my answer is 9.107, which I'm going to round to the hundredths place, which will give me 9.11. So my volume is equal to 9.11. That's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.